What's going on today? What is happening your way? This is another Pranic reading as we are proceeding in this book, as we take another look from one of our modern sages. In this day and age, we are turning the page. This is Jerome Shaw, host of the Open Palm Podcast Motivator, meditator, coming at you with the Pranic World Book, once again from Cristiana, Eltrayan. The time is at hand for this knowledge and information to be spread across the land to every woman and man. In the divine plan, we're all just doing all we can. So much love to you, my friend. Thank you for listening again. And if you haven't yet heard the beautiful words that were in the beginning, in the introduction in chapter 1, you can head back over there on the Pranic Pages playlist. But we're just going to say this. So, much love to you. And this is an informal reading, so we'll be touching here and there on a few highlights. Now, as we ending chapter 2, let's see what we have to get through. The pranic bacteria that live on pure energy. Curiosity piqued. On newscientist.com, we found a very relevant article called Meet the Electric Life Forms That Live on Pure Energy. A possible explanation on how other life forms and even humans can be nourished by prana. Unlike any other life on Earth, these extraordinary, love that word, these extraordinary bacteria use energy in the purest form. They eat and breathe electrons, and they are everywhere. Tick an electrode in the ground, pump electrons down it, and they will come. Living cells that eat electricity. We have known bacteria to survive on a variety of energy sources, but none as weird as this. We already knew about two types, Shewanella and Geobacter. Now biologists are showing that they can entice many more out of rocks and marine mud by tempting them with a bit of electrical juice. Getting it loose with electrical juice. Oh man, sounds very obtuse. Experiments growing bacteria on battery electrodes demonstrate that these novel, mind-boggling forms of life are essentially eating and excreting electricity. Wow, that sounds like a Pokemon or something. You know, like Pikachu or Electrode. Very interesting. Very interesting. That should not come as a complete surprise, says Kenneth Nielsen at the University of Southern California, Los Angeles. We know that life, when you boil it right down, is a flow of electrons. You eat sugars that have excess electrons, and you breathe in oxygen that willingly takes them. Our cells break down sugars, and the electrons flow through them in a complex set of chemical reactions until they are passed on to electron-hungry oxygen. Life's clever. It figures out how to suck electrons out of everything we eat and keep them under control. In the process, cells make ATP, a molecule that acts as an energy storage unit for almost all living things. Moving electrons around is a key part of making life, or making ATP. Life's very clever, says Nielsen. It figures out how to suck electrons out of everything we eat and keep them under control. In most living things, the body packages the electrons up into molecules that can safely carry them through the cells until they are dumped onto oxygen. That's the way we make all our energy, and it's the same for every organism on this planet, says Nielsen. Electrons must flow in order for energy to be gained. So in order for energy to grow, the electrons must flow. This is why when someone suffocates another person, they are dead within minutes. You have stopped the supply of oxygen, so the electrons can no longer flow. Good to know. The discovery of electric bacteria shows that some very basic forms of life can do away with sugary middlemen and handle the energy in its purest form. Electrons, harvested from the surface of minerals. It is truly foreign, says Nielsen. In a sense, alien. I hear the X-Files out here. Anybody ever seen the X-Files? Nielsen's team is one of a handful that is now growing these bacteria directly on electrodes, keeping them alive with electricity and nothing else. Wow. Neither sugars nor any other kind of nutrient. To grow these bacteria, the team collects sediment from the seabed, brings it back to the lab, and inserts electrodes into it. First, they measure the natural voltage across the sediment before applying a slightly different one. A slightly higher voltage offers an excess of electrons. A slightly lower voltage means the electrode will readily accept electrons from anything willing to pass them off. Bugs in the sediments can either eat electrons from the higher voltage or breathe electrons onto the lower voltage electrode, generating a current. That current is picked up by the researchers as a signal of the type of life they have captured. Basically, the idea is to take sediment, stick electrodes inside, and then ask, okay, who likes this? Says Nielsen. Shocking breath. At the Goldschmidt Geoscience Conference in Sacramento, California, last month, Xiulin Li of Nielsen's lab presented results of experiments growing electricity breathers in sediment collected from Santa Catalina Harbor in California. Yamini Janger, also from the University of Southern California, presented separate experiments which grew electricity breathers collected from a well in Death Valley in the Mojave Desert in California. Over at the University of Minnesota in St. Paul, Daniel Bond and his colleagues have published experiments showing that they could grow a type of bacteria that harvested electrons from an iron electrode. That research, says Janger's supervisor, Mo El Nagar, may be the most convincing example we have so far of electricity eaters grown on a supply of electrons with no added food. Electricity eaters that grow with no food. But Nielsen says there is much more to come. His PhD student, Annette Rowe, has identified up to 8 different kinds of bacteria that consume electricity. Those results are being submitted for publication. Nielsen is particularly excited that Rowe has found so many types of electric bacteria, all very different to one another, and none of them anything like Shionella and Geobacter. This is huge. What it means is that there's a whole part of the microbial world that we don't know about. Discovering this hidden biosphere is precisely why Jahangir and El Nagar want to cultivate electric bacteria. We're using electrodes to mimic their interactions, says El Nagar, culturing the unculturables, if you will. The researchers plan to install a battery inside a gold mine in South Dakota to see what they can find living down there. NASA is also interested in things that live deep underground because such organisms often survive on very little energy, and they may suggest modes of life in other parts of the solar system. It's interesting. I think that there's so much more than meets the eye. As we're discovering how and we're discovering why, there are so many things we know nothing about. So many things we're just discovering now. The utility of it. Electric bacteria could have practical uses here on Earth, however, such as creating biomachines that do useful things like clean up sewage or contaminated groundwater while drawing their own power from their surroundings. Nielsen calls them self-powered useful devices, or SPUDs for short. Cute. Practicality aside, another exciting prospect is to use electric bacteria to probe fundamental questions about life, such as what is the bare minimum of energy needed to maintain life. For that we need the next stage of experiments, says Yuri Gorby, a microbiologist at the Rensselaer Polytechnic Institute in Troy, New York. Bacteria should be grown not on a single electron or a single electrode, but between two. Hey, it takes two to tango. These bacteria would effectively eat electrons from one electrode, use them as a source of energy, and discard them onto the other electrode. Immortality? Gorby believes bacterial cells that both eat and breathe electrons will soon be discovered. An electric bacterium grown between two electrodes could maintain itself virtually forever, says Gorby. If nothing is going to eat it or destroy it, then theoretically, we should be able to maintain that organism indefinitely. It may also be possible to vary the voltage applied to the electrodes, putting the energetic squeeze on cells to the point at which they are just doing the absolute minimum to stay alive. In this state, the cells may not be able to reproduce or grow, but they would still be able to run repairs on cell machinery. For them, the work that energy does would be maintaining life, maintaining viability, says Gorby. How much juice do you need to keep a living electric bacterium going? Answer that question, and you've answered one of the most fundamental existential questions there is. Wire in the mud. Electric bacteria come in all shapes and sizes. A few years ago, biologists discovered that some produce hair-like filaments that act as wires, ferrying electrons back and forth between cells and their wider environment. They dubbed them microbial nanowires. Interconnectivity. Lars Peter Nielsen and his colleagues at Aarhus University in Denmark have found that tens of thousands of electric bacteria can join together to form daisy chains that carry electrons over several centimeters. a huge distance for a bacterium, only 3 or 4 micrometers long. It means that bacteria living in, say, seabed mud, where no oxygen penetrates, can access oxygen dissolved in the seawater simply by holding hands with their friends. I remember, this reminds me of a scene in one of my favorite movies of all time. Definitely one of my top 5. It was called The Prestige, where there was a demonstration with Nikola Tesla, where he was holding a light bulb in one hand, and he just extended his other hand and had his friend hold his other hand. And as their hands joined together, the light bulb turned on. It was powered by the electricity of their bodies. You know, there's electricity all throughout your body. It's powering your body right now, right? It's electric. Boogie, woogie, woogie. Such bacteria are showing up everywhere we look, says Nielsen. One way to find out if you're in the presence of these electron munchers is to put clumps of dirt in a shallow dish full of water and gently swirl it. The dirt should fall apart. If it doesn't, it's likely that cables made of bacteria are holding it together. Nielsen can spot the glimmer of the cables when he pulls soil apart and holds it up to the sunlight. Flexible biocables. It's more than just a bit of fun. Early work shows that such cables conduct electricity about as well as the wires that connect your toaster to the mains. That could open up interesting research avenues involving flexible, lab-grown biocables. It is obvious that the evolving humanity is only now beginning to discover the immense diversity of creation. And thus concludes chapter 2. Much love for you, my friend. Keep shining in all you do, my friend, for it is never the end. And this time that we spend exploring what to some might seem a new trend, but we realize there's always something new around the bend if we just allow ourselves to begin again, realizing that there's always something new to learn. So continue to keep the fire within you burning, always yearning for more learning. This is the time. Continue to find freeing your mind and staying aligned. Much love, and we'll see you as we begin chapter 3. Take care.